All right. Hey everyone. Hope we're all doing good. Let's do some math. Oh, caught my T in the shot. Get that out of here. All right. Make sure my stuff is working. Okay, good. Functions help, one comment, no one's responded. Let's see what's up with this. Ooh. And the inverse of that, assuming that's y equals that. This formatting is really hard to read. So wait, if I just focus on this line. Oh, I see. This is supposed to be a big fraction bar. Okay. So this is the step where they switch the x and the y, and then they go back and they go into solving it for y. So I want to know where that xy comes from, I guess, or maybe a different xy. It's kind of ambiguous, I guess. I need to work through this for myself because I really can't understand the way that they've written it. Just like I want to verify that their work is actually correct before I try and understand it. So first I switch the y's with the x's. And now you go about solving for y again to find the inverse. So they first multiply through by y plus 1, so let's do that. And then, I guess they multiply the x inside, you can't really avoid that, I don't think. And that's where one xy comes from, or like one of the xy's. And then, let me see if I can figure out. They added 7 to each side and brought the minus xy over to the, and brought the xy over to the other side by subtracting it. So I got x plus 7 equals 3y minus xy. And then they're presumably going to factor out, yeah. X plus 7 stay the same, you factor out the y from these two terms. 3 minus x, divide each side by 3 minus x, and you get y equals x plus 7 over 3 minus x. Okay, and that matches with their final answer too. So let's go about explaining this. Or there's so I think they understand the first part where you just switch the x's and the y's. But what did I just do? By y plus 1, x y plus 1 is equal to 3y minus 7. multiply the x inside the parentheses. Oh yeah, I forgot you need two spaces. If you want them to be on a different line. Get a xy plus x equals 3y minus 7. Side and subtract xy from each side. X plus 7 equals 3y minus xy. This is one of the things that they asked about, though, the factoring step. Allowed since each of the terms has a y. That's enough explanation. Y times 3 minus x. Hey, Spurskin. X plus 7, y equals x plus 7 over 3 minus x. Okay, and that matches with what they have. Hopefully that helps them. Let's go over to homework help, because I don't think math help had much else. This is an interesting one. So 28, it's not a perfect cube. I wonder if you like rationalize it twice. I kind of want to, ooh. Or can you solve this intuitively? Like what perfect cubes are 2 apart? What are perfect cubes? You got 8, you got 27, 64. Well, they're getting far apart pretty quick. I see you have the 56 difference too, though. That doesn't make it very clean. I bet you could figure out a way to do this intuitively. Ben! Thank you. Donnie Daddy is my given name. How's it going? So what if you added maybe the 8 minus 28 cube root to each side and cubed each side then? You're huge vibing. That's good to hear. Same here. I only just started the stream a little bit ago, and this seems like it's gonna be a fun problem. Actually, I should plug into Wolfram Alpha though, make sure it's possible. So I've been had before with impossible problems. Yeah, no, I'm good. I was just playing some games off stream just before this. 36. And I had a good time. How do they do it? I think, ooh, they get the x plus 28 to the side. I wonder if that matters. I want to work through this. So I think they do. They do the thing that I was thinking where you bring one of the terms to the other side and you cube each side. A little bit curious that they use that term instead of this term. It seems more natural to me to get this term, but I assume all roads lead to Rome here. Oh, doing the other one might be better though. What's the difference of 2 cubes? Oh wait, no, this is a different situation. This is the difference of 2 cubes. Never mind. Let's just blindly follow what Wolfram Alpha did. Let's subtract that to the other side. And then we cube each side, I would think. Yeah, you can maybe do some funky thing with multiplying by like 8 minus 28 to the 2/3, but that seems like it's making it harder rather than easier. So if we cube each side, we get that, and who knows what, I thought that would be the difference of 2 cubes, but that's not the difference of 2 cubes. That's basically one number cubed. I'm gonna make Wolfram Alpha do that for me, as I'm wont to do. Dude, my Opera browser has been right now. No way you do it like this. You get this, and like, what the heck do you do with that? Go back to the other one. I'm gonna give it maybe this step and see if it gives me the actual. You do raise each side to the power of 3. Move everything to the left side. Okay, let's keep on cheesing this. Because I'm still a little weirded out of what you actually do with this. Did I just break something? I messed up a sign, right? Yeah. It's minus x, oops, plus 28. And they expand everything out. Really? Like, this can't be right, right? Is that factor? I'm gonna keep Oh, is that sarcasm? Sorry. Oh, I didn't realize it was like right into my neck. I hope I sound okay right now. Oh, shoot. Is it better now? Hey, Jed. I just realized it was like digging into my neck a bit. It's better? Okay. Thanks for calling that out for me. All right, let me just actually move this thing a bit. Don't say math. Working on English. So someone posted this problem, and
always remember.
Oh, you got first.
You ain't first, you're last.
You know, trying to figure out for myself, I kept getting like things that don't seem like they help. Wolfram Alpha is able to come with like an actual solution though. It involves some really ugly terms. So I've been giving it each of its own steps back into it so I can see the step-by-step solutions. But basically, this is the result of subtracting the cube root a plus 28 to the other side and cubing each side. And then they brought everything back over all on the same side, and now they're simplifying things. And the simplifications are weird. That doesn't seem so bad when they put it like that, though. Hard locked first. You know, just you're first if you just like don't look too hard, squint your eyes a bit, dude. I'm still trying to figure out what my next Twitch payout is gonna be, but I think I might save up for an actual like real lap mic that can plug into this one, because this thing is just being annoying. Stream really does not start until you get here. There you go. We're all just waiting for you. Wait, do both radicals have plus under them? On Wolfram's view? Here? Oh, because we got rid of the one with the minus because when we cubed each side, the one with the minus combined into the other terms. And actually, I'm about to do this step by hand anyway. But when we do this foiling, we get multiple a plus 28 terms. And this a minus 28 that tracked down to here is going to get combined with other like terms. So it is right that we're getting that. Ooh, I shouldn't do that in my head. If it was squared, I would do it in my head, but I'm not going to do a cubed in my head. I said a -2? Because there's the minus sign in front. Oh, sorry, it's the -2. Because I subtracted this. Thank you, Jed. I'm sorry. So first I was subtracting that term over here. So that this term stayed the same over there, and the 2 stayed positive. Okay, so the expansion of that is minus x. God dang it. I'm also gonna buy actual markers that don't die on me like that. And they actually erase nicely. I'm just using x with Wolfram. Oh, I was copying Wolfram Alpha's work, and I'm using x with Wolfram Alpha because I don't want to confuse it. But you're right, I should keep it in A. Now we get everything over onto the other side. Minus a plus a is 0. 28 plus 20 is 48. Minus 6x plus 28 to the 2/3 plus 12 cube root x plus 28 equals 0. Okay? I keep on writing x. A just breaks my mind, I guess. Okay. And then what Wolfram Alpha did is they made a substitution. This time I actually will use x. X equals cube root a plus 28. And that simplifies it in a pretty beautiful way. Or it makes the problem look so much nicer. Minus 6. 2/3 is x squared. Then that becomes x. And that's just a normal quadratic. Let's factor out a minus 6. Right? Okay. That factors with x minus 4. X plus 2. So x equals 4, negative 2. Now we have to remember this substitution to actually get what a is. So we have 4 is equal to cube root a plus 28. And we have negative 2 is equal to cube root a plus 28. So let's cube each side. We get 64 equals a plus 28. And we get negative 8 equals a plus 28. Really? One of these answers can't make sense. We're gonna need to plug both these back into the original. Because the answer is, according to Wolfram, is just 36, which comes from this one. But we also get a minus 36, never mind. Or probably still, we plug minus 36 into the original. We get minus 8 cube root is minus 2. What the heck is that? Hey, Drew. That's a 64. Cube roots are 4 and 2. Okay, thank you. So minus 2 minus negative 4 is plus 2. So why does Wolfram Alpha get A's plus and minus 36? Am I missing something? If we do positive 36, that should also work. So you get 4 minus 2. Yeah, I think it's plus and minus. Yeah. I wonder why Wolfram Alpha only gets the positive solution, not the negative one. Let's look and see if they made an assumption. Standard computation time exceeded, that might be why. Let's give it the original as well. Oh, that's not what I want. Wait. Oh. They're just throwing out any complex roots, I think. Negative 36 is still real though, so it should have gotten that in theory. Let's just do another sanity check. Let's manually plug in negative 36 here. False. Why are you false? What? That's negative 8, which becomes negative 2. That's negative 64, which becomes negative 4. Does Wolfram Alpha not know what... Do I not know what to do cube root? Wait, okay. Why does it think that's imaginary? What? Oops. What? I pressed F11. Well, I think Wolfram Alpha doesn't know what a complex root is. The cube root of -1 is -1. Am I crazy? Is the cube root of -1 not defined? Oh, you could also have an imaginary solution? But why isn't Wolfram Alpha... Okay, thank you, Jed. The principal root is imaginary. Oh, you're right, Druha. I mean, Jed's the one who found the actual thing. Oh, is there an actual link? Oh. Interesting. So there's imaginary solutions to this.
Oh my.
Too, aren't there? There's plus and minus 36. I didn't notice that was an actual link. I'm sorry, Jed. So up to the point where we have plus and minus 36, I think we've gotten all the possible solutions, but then we introduce... So there's 6 different solutions. 2 of them are real, 4 of them are imaginary, I think. And my browser doesn't want to cooperate with me. That's great. I love it when that happens. Let me get rid of some of these. Oh my god. Why? I X'd this thing out like 10 minutes ago. This frickin' browser. Okay. This is literally unusable right now. Let me close out this browser and just reopen it. If it's still being stupid, I'm gonna go to Firefox. Trick question. Okay. Let me go put my mug away because I'm having tea. Okay. So the person was saying that you can get Wolfram Alpha to give you the solutions if you do x cubed is equal to how many fourth complex roots of 1 are there and what are they? So I assume the trick is that the easy answer would be 4, but I think you get repeated roots. Maybe. Because I to the 4th comes back around to being 1. So I assume 1 and I are definitely roots, but actually no, there probably are actual, like, I don't think repeated roots may make sense for that. Maybe they do. One might be a special case. I don't know. Let me I want to figure out this one. So it's when we plug in positive 36, we get the oh wait, it has to be equal to 2 though. The imaginary solutions might not apply. X cubed is equal to 64. Well, for that one, it should just, I assume, well, I guess we could also get complex. Yeah, we do get. The answer is 4? Okay, so it is 4. Hey, Zach. How's it going? One, negative 1. Negative I comes back around to being 1? I assume to go back to being negative I. Oh, I guess because you can split the negative 1 out. It just becomes I to the 4th. Should I even get into the complex solutions? Oh no! Okay, so these people both got it. I do want to say, I'm going to add on the bit about Wolfram Alpha. Equals 36, but A equals negative 36 also works, and I'm going to say there are properly complex solutions, because I don't completely, there are probably solutions. I assume there's complex solutions that still give you the real result. I wish I could make Wolfram Alpha. Was there a link on that first one to get the principal root? No, it's being too slow. X plus 28 cube root x minus 28 equals 2. The real valued root. Oh, see, now it gets plus and minus 36. Well, for a cube root, would you only take the real solutions though? But if negative one cubed equals -1, why can't the cube root of -1 equal -1 if you're restricted to real numbers? If it's just not defined, I believe you. I'm just like confused by that though. Or it's just like, you know, the same deal as dividing by 0 then. Okay. Right. Oh, and that over 6 is the issue because it has a square root hidden inside it? Or, you know, there's no solution for -1 to the 1 over 6? Oh, but oh. Huh. That's interesting. It's kind of annoying, I guess, that you can't just say that, but I guess that makes sense. I don't get what they mean by magnitude in this problem. This is a 3-dimensional line. Yes. Or no, it's only 1-dimensional. It's just a normal line. I guess the magnitude is just x squared plus y squared square rooted. I just feel like I never heard about people talk, my class, I feel like I never talked about magnitude in like this context. Okay, but I'm not the only one, Zach. And if they just give you the point, wait, what are the coordinates of the points? What is p of -1, 2? Is that just the coordinate that you need? I don't get anything about this question, I'm gonna be honest. Oh, okay. I still don't understand what they're asking for, though, I guess. Maybe they mean the distance? It could be that too, with slope. I feel like what they're asking are the 2 points on the line that are 4√5 distance away from -1, 2. I think it's the best interpretation that I can come up with here. This seems like it might have been translated from a different language. If it is that question of which 2 points are that given distance away from the point, do we make a circle or how do we actually solve that? Yeah. So don't do the poorly worded questions? I mean, a lot of times I don't, but I feel like I figured out what the problem is, though. Okay. So, I mean, we could put this into a normal line. I don't know if that's better or worse. But if we have x equals 3 plus 2t, why am I back to using black? The black markers are already dead. Let's try out blue. Blue's holding up okay for now. 3 plus 2t, and y is -2 plus 3t. Let's solve each of these for t, then equate them. Wait, I'm getting my signs backwards. Right? Okay, and then that's t equals, let's equate these and these. Multiply everything through, I guess, by 6. Okay. I guess let's solve it for y to get an our familiar y equals mx plus b. Okay. Could always use chalkboards. I know I use the chalkboard. I hate the feeling of the chalk on the board. It just, I don't know. The few times that I have written on a chalkboard in my life, I just like, it makes me cringe. So I don't know how you do it. It's better than dried out markers. That's true. It is that you don't have to worry about your chalk drying out. So I guess we could verify the point -1, 2 is actually on this line. So I don't know if I even believe that. And actually, the question might still make sense if it's not on the line, now that I think about it. 2 is equal to -3/2 minus 13/2. Yeah, no, that's not true. So okay, this problem has a little twist. Oh my god, dude. Okay, the chalk is starting to sound better with all my markers being dead. I'm just gonna have to buy some new markers. I didn't link to ones that are better than these, like, random expo ones. Well, the expo ones aren't random. I thought they'd be actual good markers when I bought these, but evidently not. So if we have 13 over 2 is about 6.5. Or it's exactly 6.5. 3 for 5, 6, 7. 1, 2, 3. Up. Wait, rise over run. Up 3 over 2. Okay. And then we have the point -1, 2. Which is all the way up here. So hopefully there are some points that are... Well, 4 root 5 is about 8. So there definitely are going to be 2 points that are intersecting this line. And this is... That's not at all a centered circle, but I ran out of room up top, so... So we could just actually make the circle and intersect them. That might be the best way. Or we could... Honestly, I think I like the circle idea the most. I feel like there's multiple ways to do this. But I want to get the equation of that circle there. Ow. So the equation of that circle is... what is it? X plus 1 squared plus y minus 2 squared equals radius squared, which is 16 times 5, which is 80. It's a 1. So I guess you want to solve that for y and equate them and solve for x. Oops, x plus 1 squared. Okay. Now let's follow through. Technically it should be plus and minus. That's where we're gonna get, or yeah. I'm gonna look at the plus first, but we are gonna get 2 solutions, so we do want to keep that plus and minus. 3 over 2 x minus 13 over 2. That's an annoying one to solve. Let's get the 2 to the other side and square each side. 13 over 2 minus 2, 4 over 2, 17 over 2? They're not nice points? Ooh, that makes me worry that I'm interpreting the problem wrong then. Um, 80 minus x squared minus 2x minus 1. I guess I gave everything over onto that side. 2x plus 3 over 2x is 7 over 2x. 17 over 2 plus 1 is minus 15 over 2. And I'm going to try to do minus 15 over 2 over 80 in my head. Or at least now I have it written down, I might, but that's not going to be easily factorable regardless. So we'll probably find the roots and see what they look like. X squared 0 equals x squared plus 2 minus 15 over 2 minus 80. yeah. Oh, wait. No, no, not, wait. Ooh. Only one of those solutions is right. I think. Only one of those solutions applies to this problem. Because we have to check if the circle intersects the line. Well, the circle definitely intersects the line once in the lower part, and the other one could be in the upper or the lower. I'm not really sure. So we'd have to verify that these points are actually on the line. But even then, that doesn't look pretty. If we had, let's look at the ones with minus. If those look nicer, I might think that it's those. 2 minus square root 80 minus x plus 1 squared. You only get one solution, Wolfram, and it's not very pretty. Now I'm worried that I'm interpreting the problem wrong. I almost don't want to respond now. But assuming that there's one that intersects the upper half, one that intersects the lower half. I mean, that's not the worst thing in the world. Maybe I should post this and just say what my interpretation of the problem is. I think I'll still post here. Is a bit hard to understand. My interpretation is that you're given the line defined parametrically by x equals 3 plus 2t, y equals negative 2 plus 3t. And you have to find the 2 points on that line that are 4 square root 5 distance away from the point minus 1, 2. How I did this is by converting the parametric equation, the normal, to the normal y equals mx plus b form. Then I made a circle. I'll give what the actual line is. Big editor? Oh, to actually like see what I'm typing, yeah. Y equals 3 over 2x minus 13 over 2. Made a circle of radius 4 square root 5, centered at negative 1, 2. X plus 1 squared plus y minus 2 squared equals 80. Circle for y to get y equals 2 plus and minus square root 80 minus x plus 1 squared. Can then equate the circle to the line and get one solution by taking the plus in the circle equation and the other solution by taking the minus in the circle equation. Okay, and that's all I'm gonna say here. I don't wanna go on a huge explanation when I'm not even sure if I'm understanding the problem right. I think I am, but we don't get the cleanest answers out of this, so I'm a little bit wary. Let's post this. I got mail. Oh, okay. I don't know if I have to comment on this, so I'm just gonna leave that as is. Might be oh dude, I can't type. I make mistakes like that all the time because I proofread and then I make small edits, but I forget to like make my edits apply to the entire sentence and make the wording make sense again. See what Jed posted? This one is fresh, hot off the presses. Wait, this song already played. It's just playing songs off this one album. Wait. Okay, there's one that's not on the same album. Okay. There you see. Differentiate both sides. Try to equate my answer to -1. Know what to do with the y's in the equation. So they do product rule on this term. They applied the product rule correctly there. Product rule on this term, they did it correctly there. Solved it for dy by dx. The numerator looks perfect. The denominator should be 4. No. It looks good too. I assume you would solve this for y and you end up getting infinitely many solutions at this point. Yeah, this does look like a fun one. Maybe you can't solve this for y, actually. It looks a little bit hard to solve. The triple exclamation, yeah. Differentiate a triple factorial. You'd have to use the gamma function. I don't really know the gamma function though. I don't know how you do this. If you could solve this explicitly for y or x, then you give them an equation for all the points where the tangent is -1. Or like, you know, some kind of function that defines all your points. I don't actually know how you do this though. Let's refresh and see if anyone else got to it. Could make a Wolfram Alpha's problem. That is one of my favorite things to do. What's their partial? Minus 2xy squared minus y minus 2x. Oh, thank you, Wolfram. That's what I wanted to type. Squared. I have to do it in parentheses because Wolfram Alpha is going to think that I want to square that entire term, and I don't. 2x squared y plus x. You could cancel a y from the top and bottom, I just noticed. No, you can't. Never mind. No, I don't know how to do this. Wolfram Alpha doesn't know either. So I think I'm just going to move on. That is an interesting question, but I don't know for that one. Always have comments on them. Let's look at this one. I never learned PDEs, so I was a little bit scared to look at that one. They also posted it in Ask Math. I know partial differentials. I might have learned about 1 or 2 partial differential equations, but I'm just so little about them that it had to be something very basic or else I wouldn't be able to answer it. Even then, Felix sounds familiar, like they posted other things too. I don't know what the line means, but I guess n is equal to, you know, some string of factors. T of n is equal to the absolute value of all the factors plus and minus. Oh, of the digits. That's what the line means. Oh, really? I wonder if there's a way that we can get that algebraically. Because that is like a pattern right there. I'm not sure how you do that though. The person mentioned getting y equals 1 over x in their thing. I thought they were just like messing around with doing random math though. It wasn't actually anything that meaningful. Right, because this one in the first quadrant is decreasing. And this one in the third quadrant is also decreasing, which is just, or it's a shape of 1 over x. It might not match exactly. That one was one. Oh, yeah, that was the one that Jed linked. Just saw it in my copy paste. We can graph our partial as well. Well, yeah, we could. Really? So basically, wait, it keeps on wanting to play the same song. It's not a bad song, but I want some variety here, Chill Hop. Just choose a random song. So what happened, I guess, or so let me just try and like understand this. We have x squared y squared plus xy is equal to 2. We solve this in terms of xy, or you could make t equals xy. I'll just keep it in terms of xy. Bring the 2 to the other side. And now we factor that like it's a normal quadratic. Xy plus 2, xy minus 1. So that means, okay, then we get 2 possible solutions, which is y equals minus 2 over x, or y equals 1 over x. And what we did is we made that substitution. Well, we don't even need to get the implicit derivative, do we? We can just take that as our equation. Of that one. That's only equal to when x equals plus or minus 1, I guess. And for this one, if we were trying to do the same logic with this one, we don't get any solutions. Unless you want to include complex values, we don't get any solution out of that one. Okay. I can buy that. I never thought of, that feels almost dangerous to me, factoring like that, like you're going to lose information, but I see what you're actually losing. It just... for this one, because that's positive 1. Yeah. Probably didn't write it too clearly, but yeah. All right. Thank you for the shout on that one, Zach. Actually, that's a save. Yeah. I assume they're only dealing with real values though. Oh wait, so does that mean that's the first and third quadrants are exactly y equals 1 over x, and the second and fourth quadrants, they are... Oh! And the other 2 quadrants are exactly y equals minus 2 over x. That's kind of funny. Where's that one? Okay, there. Y sub 1 equal to 1 over x, and y sub 2 equals minus 2 over x. Then y sub 1 prime is equal to minus 1 over x squared, and y sub 2 prime is equal to 2 over x. Oops, I don't need that outside parentheses. From y sub 1, from y sub 1 prime, I should say, this equals plus and minus 1. There are no solutions. Or actually, from setting to negative 1, we get x equals plus and minus 1. Setting y sub 2 equal to negative 1. We don't get any solutions. So x equals plus and minus 1. Okay. Hey, Brian. All right, that's a nice little problem there. It really is just simplifying it and deriving it. It's so much more common to do it the way this person tried and the way that I tried too. With taking the implicit derivative like that and setting it equal to negative 1. Okay, this might be a stupid question to who, but do you get snow where you are? They must use, I think they say this is equal to sine. Ooh, what would they do? They need to break the 13 pi over 12 strategically. And then use a sum identity. Oh, a new like a math streamer? Who are they? I've been meeting a lot more the last maybe like month or so, and it's been great. Oh, I was asking if you get snow where you are. Twitch Lord. Hey, too risky. A new Twitch Lord. Nothing much with me. How about you? Who are they? Who? I'd love to. Oh, just like if it snows there, like also doing like the snow sports, but just like Okay, so you just stay at home. In general, there's like, you know, does it like snow there? I know it does like on the mountaintops and stuff, but I don't know how much like snows generally like in France. You don't think so? Okay. For this year? Oh, okay. Yeah, I'm just curious, like, in California, I've seen snow maybe 3 times in my life, and I've had to travel for all of those. Like, it just never snows where I live, and it makes me kind of sad. Okay, so if you have 13 pi over 12, how do you break that up strategically? They seem to only need to break it up once, which I don't know how you do that. How can you do sine of pi over 12? Because you can break it up into, well, I guess you clearly don't break it up like that. Talos teaches? I have not heard of them. I'll have to look them up. So I always like to meet new streamers. Thanks for letting me know about them. No, I haven't heard of them. It's always interesting 'cause, like, even then, like, I thought that there are a lot more math streamers than I thought there were, but there still aren't too many. So anytime that there is a new one, I'm interested to hear. Oh, maybe solve sine of pi over 12 using a subtraction identity. Oh, maybe subtraction is the way to go with this. If you did maybe... Actually, we can reverse engineer it. See, if you have a plus in the middle there, then I think it means it's a subtraction identity, right? No, it matches, so we do addition here. So like 8 and 5 doesn't really work. You could do 6 and 7. That doesn't really work either, though. So you want to break it up 3 times, but it seems like they only break it up once with that work. You could do 12 pi and 1 pi, but then you get sine pi over 12, and I don't know what to do with that. Let's give it to Wolfram Alpha and see if it gives us the simplification. Oh, maybe a cosine. A third minus a quarter. What do you do with a 13, though? Maybe I'm being slow. Maybe you do need to do something like that. Really? Third minus a quarter. Feels a little wrong. Unless we maybe... Wait, well, if we combine the pi and the minus pi over 4, we get 3 pi over 4. That's a unit circle. And pi over 3 is a unit circle. So that might be it. There might be like a... which would be 4 pi and 9 pi. Which adds up back to 13. Okay. I think that works. Yeah, that's I like that. Do you know what is Christmas? Red flag. Too cold. I like the cold, honestly. I wish I lived in a cold like part of the world. Then again, it's like 70 degrees out today, and I'm wearing a hoodie, so maybe I wouldn't be able to handle it. But okay, so the identity is sine theta, which we'll take as pi over 3. So good shout on that, Too Risky. Thank you for that. Times cosine. Traded. Oh, do you live somewhere cold? Yeah, I'm sure if you like have always known that you get, or I'll get like sick of it too. But I've only known hot California. Plus cosine theta. And I need my unit circle because it's not in the first quadrant for 3 pi over 4. Unit circle. Okay, sine pi over 3. Let's just use the unit circle. Root 3 over 2. I should do that in my head so I stay sharp on it, but you know, YOLO. Cosine 3 pi over 4 is minus root 2 over 2. Cosine pi over 3 is 1/2. Sine 3 pi over 4 is positive root 2 over 2. Okay. Let's see if that matches with what the solution was. You grew up in Arizona, but you live in Vermont now. Oh, okay. Arizona. I've gone there for a cousin's wedding, and just walking out of the airport felt like walking into an oven. I definitely would not want to live. So like, this is like already like I'm in Northern California, so it doesn't even get as hot as Southern, but this is still like way too hot for me. So I couldn't even. I would never want to live in Arizona. Like weather-wise. Vermont sounds pretty cool, but I've never been there. 3 over 2 with the minus root 2 over 2. Okay, good. This does match. Did I refresh? Let me refresh again. Then we broke it up as 4 pi over 12 and 9 pi over 12. What is this one called? Some identity? Sine pi over 3 cosine 3 pi over 4 plus cosine pi over 3 sine 3 pi over 4. Okay. Nice little question there. Limit as x goes to infinity, e to the negative x, x. You would L'Hopital's this. It's probably a little bit small in stream, but it's e to the negative x times x. And if you L'Hopital's, you get 0. No. Yes. No? Yes. You get 1 over e to the infinity, which is 1 over infinity, which is 0. Let's see if they can pick it up from here. If not, I'll give them the next hint. Right, that's the one. Let's see if they say L'Hopital's for themselves, or if I need to help them with that. Oh. Someone else is typing. Let's see if they just give it away. Which there's no rule against that, so. If they jump in and just say it, then that is what it is. Okay, yeah. So if that person wants to do it, I'll let them handle it. What more to do? How to solve this using square roots property. Algebra 2. Let's make that bigger because I can't read it. Oh god, even if I zoom in, it's not that much better. One half r squared minus 10 equals 3 over 2 r squared. So subtract the 1/2 r squared to the other side, you get just r squared equals -10. Really? Isn't there no solution? Or if you did the opposite, and then minus 3 over 2 r squared from each side, you get minus r squared minus 10 equals 0, which, no, that's not true. There's just no solution. Okay. No real solution. You're right. They might be getting into complex numbers. That's a good point, Jed. Because I think Algebra 2 is when I learned about complex numbers. Now how you solve this depends on how your class is being taught. You might have no solution because no real number squared can be negative, or you might have an imaginary solution because, well, let me do the next stage. Each side to get plus or minus square root 10 equals r minus 10. There's no solution because you can't square root negative numbers, or you might say the solution involves imaginary numbers. I learned about them in high school in the context of the roots of parabolas, and that's basically what this is. So the fact that they're saying algebra 2 means it could kind of go either way in my mind. Ooh. Has an acute angle with the x-axis. I assume there's a typo with like x prime x. I assume they just mean x-axis. Kind of a fun one. I mean, really, because we're talking about a two-dimensional function, you either have a positive slope, which is an acute angle with the x-axis. Well, ooh, wait, positive or negative x-axis? Because you can always form an acute angle with the x-axis. This is ambiguous. It might not be an acute angle it's not gonna be an angle like how it's defined with the unit circle, but oh, okay, that's true. You got me there, Jed. Well, x equals 3 isn't a function, though. At least by the normal definition of function used by a calculus class. Even if it was 3 dimensions, would that change anything? No. You can, even in 3 dimensions, you can always make an acute angle with the x-axis, right? Unless it's exactly 90 degrees. We're talking about the tangent line, not the function itself, right? Or does that... Yeah, no, the tangent lines to y equals 1 over x that definitely form acute angles. Except at x equals 0. Unless they put more stipulations on, or unless they put more, well, yeah, but the question here is about tangent lines. A line will always form an acute angle with the x-axis. You're just trolling. Oh, okay, okay. A vertical or horizontal. And so with their question in particular, I think that might, I mean, I feel like the way that I phrase it is more clear, even though it's not perfect. The vertical line will be whenever the denominator is 0. E to the x equals 0, which has no solutions. I think that's all I want to say for now, because they might have not posted the entire question. So the whole, like, this little part of the question is tripping me up. Like, does that mean something that I just don't know? Or is it a typo? I was assuming it's a typo, but it might not be. Or I'm misinterpreting. Okay, let's post that. No one helped with this one? Doesn't seem that bad. It's because you can factor the x squared minus 4 into x plus 2 times x minus 2, and the x minus 2's will cancel. F of 2 is not finite. Well, yes it is. And the limit is also finite. They should be the same though. I mean, F of 2 itself is not finite, unless you've already done that simplification. I think it's because the limit is finite, but F of 2 is undefined. Anders hasn't been here today in Penn Centers. Polynomial operational. I guess I did see this, but I didn't look too much into it because I'm not that good with this kind of stuff. It just looks like polynomial operator based off the Spanish, like, wording, but I don't know if that actually, if that's a special name or anything. A linear operator on a polynomial. Is that just a linear transformation that happens to be on a polynomial? I don't know. This is a my linear algebra class is not that rigorous, so I'm not sure about this one either. Yeah, I can't think of what it will be. If polynomial. Oh. Yeah, then I definitely don't know. I never had to do that. I mean, polynomial operator almost sounds kind of appropriate in that respect then. I just like Google that. That's too advanced for me. Maybe it's not a thing though. I'm not saying. Okay, this thread seems like it's asking about the same thing, but they don't seem to say a specific term, so. It just seems like, in general, you can write a polynomial in terms of a matrix, I guess? I never knew about that, but I guess that makes sense. So, yeah, I'm not sure. I mean, we could look at this Jordan normal form theorem. I feel like I've heard that name, and see if it has anything that might be helpful. No, I don't know. Sorry about that. Yeah, no. I could spend a lot longer Googling it, but I'm not sure. For this one, they asked this question like over 2 hours ago, so they may not be checking this anymore, but let's at least see. I do actually want to graph this quickly, just to make sure I'm not going crazy. X minus 2 over x squared minus 4. To make sure that I'm saying the right thing about, okay, so at x equals 2, there should be a hole there, but Wolfram Alpha doesn't really show it. So this isn't defined for x equals 2 technically. So the actual value doesn't exist. The limit does exist though. Actually, does the limit require that it actually be defined there? I don't think it does. I always get mixed up with that question, but I don't think the limit I think the limit can be defined even if the function isn't defined there, I want to say. I always forget that little nuance though. Actually, yeah, it must exist for I mean, let me just Google this. Because now I'm starting to question myself. I'm like 99% sure the limit does exist when it's just the removable discontinuity. Okay, yes, it does exist. Let me go back to this. It is not defined. Actually, even if you do the cancellation, it's still not defined. Discontinuity. So I believe you'd want the third and fourth boxes checked. Yeah, C and D are right here. The first one being combined is kind of throwing me off too. Yeah, I'm pretty sure it's C and D there. I didn't comment on the second one, but if they replied to me, I guess I will. Okay, so this person didn't reply. I did fucking Fartis. Okay, that person, I assume their question is solved if they are not getting back. This person, okay. I don't think I've talked to any others. What was that one? A bind a goat? Whatever that means. What percent is R of S? Wait. Do you even need the first fact? What percent of S is R? R is 20% of S? Wait, isn't this just, wait, the 20% isn't giving us an answer. This doesn't make sense. It should be what percent of S is X if you're going to use every fact in this question, right? Like, there has to be a typo. If it is that question, you do, I guess 0.5 times 0.2, or 0.05 times 0.2, which is 10%. No, 1%. So let's saying what percent of S is R, and they will say R is 20% of S, so it should just be 20, I feel like. E 20% given. Just write in. They wask? They ask. Don't wask me anything. Or what percent of S is R? Oops. And just be seems weird. We interpret it. It might be supposed to be what percent of S is X, in which case we do 0.2 times 0.05 equals 0.01 equals 1%. But that wasn't the question. It might be, okay. It's Donglish. It could be, maybe it's supposed to be. There we go, that's more clear. That's English rather than Donglish. Donglish sounds kind of gross, I'm gonna be honest. Just that word. So it seems to me that it would be 20%, as you said. There we go, let me add that in. I see they're typing back, so, oh. How long have I been going? I've been for nearly 2.5 hours. Let's make sure I don't have anything new, any replies on Reddit. Oh, I do have a reply on Reddit. I might switch over to games. Oh, okay. So when you share your Amazon account with your parents. Exactly, yeah. I don't know. I could continue my Talos principle, or I could do Phasmophobia. I mean, do you want to do some Phasmophobia, Judd? Yeah, well, let's do some Phasmophobia then. Probably supposed to have the start of the stream. I might send him, or I'll send a message to him in case he's around. I do need to use the bathroom first, though, so it's going to be a minute for me. Pause the music. So yeah, if you're just here for the math, I'm going to wrap up shop for that for the day. So thanks for hanging out.